Welcome back for those of you who are choosing to join me on these extra couple of examples. Example 2 here says to find the length of GH in the figure below. So the process is exactly the same, but what you might not, or what might trouble you, I should say, is that there isn't a sector fully drawn out, but it does tell us that we're trying to find the length of GH. So our sector actually would be from the center to G, across the arc to H, and back to the center of our circle, and that is the arc that we are looking at. And that arc, well, that's the sector we're looking at. The arc would be from G to H. So if we're trying to find the length of G to H, we are working with just this section and our 40-degree angle, but it does require us to have the radius, which is listed here as 6 meters as well. All right, so using my formula for this problem, I have arc length, or the length of GH, is equal to 2 times pi times the radius, which we just mentioned was 6, times the fraction of our partial length around our circle, which takes the degrees of 40 degrees and puts that over the total of 360 degrees that are in a circle. So now that I have that, I'm going to go ahead and simplify this a little bit. I have pi times 6 times 2 is 12 times 40 over 360. Usually I just leave it there, but if you notice, 40 over 360, they both have a 0 on the end, so there's a quick shortcut we can take, and we can just slash those zeros off, and that leaves us with 4 over 36, which is a nice shortcut and makes solving quite a bit easier. And there's another fraction shortcut I'm going to take. When I'm looking at this, I'm recognizing that I have 12 times 4 over 36. 12 goes into 12 because it's the same. And 12 also goes into 36. It goes into 36 3 times. So I actually can divide 12 out of my fraction, and that actually leaves me with the simplified version of pi times 4 over 3, 4/3. So now when I multiply that out, I'm going to do 4 divided by 3 times pi, and I do use the pi button on my calculator. When I multiply that out, that gives me approximately, for my answer, of 4.19 meters. So the arc length, or the length of GH, is about equal to 4.19 meters, or 4 and 1900ths meters would be how you would pronounce that. All right, let's go ahead and move on to example number 3. Example number 3 is going to require us to draw a picture. It just makes our lives a lot easier. It says the minute hand of a clock with radius 9 centimeters moves from the 12 to the 4. What is the distance traveled by the tip of the minute hand? All right, so I'm going to start by drawing the clock. I'm going to do the best I can to draw a circle there. And on the clock, you have a 12 at the very top, you have 6 at the very bottom, you have 3 to the far right, and you have 9 to the far left. Now we're going to go ahead and fill in the numbers between them, and they are evenly spaced as you go around. We'll do the best we can to make that appear in our picture that way. So I have 1, 2, 4, 5, 7, 8, 10, 11. All right, so there's our hands of the clock. Or, sorry, there is our clock. We have to put our hands in there. It starts in the center, and it says that our hand travels from the 12 to the 4. So if it's going from the 12 to the 4, it's going around 1, 2, 3, 4 spaces out of the total of 12 spaces. So the fraction that we are working with is 4/12. If you so choose, you could figure out that there's 360 degrees around the clock, and you can take that 4/12 and you can figure out how many degrees you're working with. But this is a different situation where you don't actually have to use the degrees if you don't choose to use the degrees. You can simply use that 4/12. That fraction is going to be the same as whatever degrees you calculate. So if I were you, I wouldn't go through that extra work of trying to figure out the fraction of degrees you have. I would just use your 4/12. Makes your life a whole lot easier. And it'll make your life easier too if you simplify this fraction. 4/12, well, 4 goes into both 4 and 12. 4 divided by 4 is equal to 1. 12 divided by 4 is equal to 3. So if you have 1/3 that you're using, it's a lot easier than 4/12 even. So let's go ahead and use that fraction in our formula to find the length of the distance our minute hand traveled. So we have that formula again of we're working with arc length. So we have 2 times pi times the radius, which was written in our problem, of 9 centimeters, so times 9, times the fraction of the partial area, which we found to be 1/3. Times 1/3. All right. So now we have our 2 times 9, which is equal to 18. So I have pi times 18 times 1/3. This happens to simplify again. 18 times 1 is 18. 18 divided by 3 is equal to 6. So what I really have is 6 pi. When I do 6 times pi, that gives me approximately 18.85 centimeters. So the distance traveled by the minute hand is 18.85 centimeters. So because this is a story problem, you do want to make sure that context is in there. So we're going to go ahead and write this as a sentence. So we would write out the distance traveled by the tip of the minute hand is 18.85 centimeters. And that whole sentence is your answer.